that children can easily learn and understand. Encouraging children to use these steps reinforces 21st century skills like critical thinking, teamwork, and creativity. The best way to understand the engineering design process is to see it in action. In this video, we will watch children as they ask, imagine, plan, create, and improve solutions to engineering design challenges. In the process, they will learn valuable problem-solving and thinking skills that they can use in other areas of their lives. Before starting any project, all engineers, children included, must ask and answer questions about the design challenge. During the ask step, children should be encouraged to think about what they need to know in order to solve the problem they're presented with. Some questions might be about the science behind the problem. Others might be about the specific goals of the technology they're creating. And others might be about the materials that they're going to have to work with. In this clip, we see third graders in Fairfax, Vermont practicing the ask step. Sandy Brown has introduced her students to a design challenge in which they need to use a mirror to reflect the light from a flashlight to different parts on the inside of a box. She challenges her students to think deeply about questions they need to answer in order to produce a successful lighting design.
Now, you get to ask me questions. We're going to be in the ask stage right now. What do you want to know about this project? Lexi?
What kinds of materials are we using?
What type of
materials? Do you get different light sources like CRT or what properties of materials have?
So I'm going to stop for a minute, and what I'm going to do is show you the first one. I'm going to show you what materials will be available to you.
Asking students what they need to know, rather than telling them, provides an opportunity for students to think critically about what exactly the problem is and how they might start solving it. The ask step helps them to begin to identify as problem solvers. Let's take a look at another class, this time in 5th grade. The teacher, Deborah Kelly Thomas, is having students review what they know about magnets to prepare for a magnetic vehicle challenge. At this point, Kelly students have spent several hours on the ask step. They've explored different types of magnets and how strong they are. They've looked at the materials that they'll have available during the design challenge. And they know how their vehicles will be tested for safety and efficiency.
Remember, we're still in the ask phase, so I want you to stay on the front sheet. And in the packet, it's asking you to list 2 properties of magnets that we can use that will help us to design our maglev package transportation system. Okay, let me share with you what Corel put. Corel says, property 1, the repelling of the poles. She says this property is important because if you don't put the same poles together, the train would not levitate. Okay? So that's a property of magnets that's going to help her in designing her maglev system.
I'll just pause here for a minute simply because I wanted to point out the fact that if you see some of the vocabulary they're using, that's quite high even for our middle school, right? That is why, and I'll talk about it more when you look at the resources, that is why in each of the units in our science, you have the key vocabulary identified before the unit. So, it highlights to us as teachers, A, the reading in science, that is what is the reading even you and I need to do before we go to the classroom because some of these are quite complex. B, it highlights to us what is the vocabulary students need to be successfully accessing that content within this unit, okay? Because it is theme, exactly. So in that sense, I would also recommend to use that vocabulary, print it out, copy, laminate, put it on your walls when you're doing the unit, okay? Because that is the first step to differentiation, right? And then we'll talk about the guided, directed, and flow practice, but I think it begins with setting up that environment for learning, okay? If I don't even know
To be familiar with all content.
exactly, if I don't even know those familiar words, how will I build is a sentence, right? So I just wanted to make a pause for you to have a look at it, and I'll talk about it in the student edition.
Although students continue to ask and answer questions throughout the unit, this first step provides all learners with the baseline information they need to know to move forward. In the second step of the engineering design process, Imagine, students start to brainstorm solutions. In this step, the goal is for students to independently come up with ideas, and they're encouraged to think creatively and without judgment. Individual students may respond differently to this type of challenge. Some students may not be as used to imagining more than one way to solve a problem. For others, brainstorming multiple possibilities is a true strength. As a teacher, it's important to acknowledge both the struggles and the rewards of navigating the Imagine step. In this next clip, first graders are imagining different ways they might move pollen from one plant to another by hand. Their teacher, Julie, explains what she expects of her young students as they go through the Imagine step.
If we started with ask, where are we today?
Imagine.
We need to go to imagine. We have 4 different boxes, and you know what I'm hoping for? I want you to imagine one way of building a hand pollinator and drawing it right here. Label your pieces, your parts, label it so you know what you planned there. Then think of different materials and a different way to make a hand pollinator for box number 2. And yet a different one for 3 and another different one for 4.
The Imagine step allows students to experience the innovative, creative thinking style that has led to many of the world's engineering breakthroughs. In this next clip, Corey Christensen prepares her 3rd graders as they start to imagine solutions for an aerospace engineering challenge. They're to design a parachute to land on another planet. Before they brainstorm, Corey provides examples from history to impress upon her students the importance of thinking outside the box.
How are some of the most important inventions created? By imagining them and just crazy, outrageous ideas that many people said there's no way that could work. Do you think everybody thought a person could go to the moon? No. What do you think that a lot of people probably told them? Justin? It's impossible. You can't do that. And so if they just said, okay, yeah, you're right, I'm going to stop, then we wouldn't have airplanes. We wouldn't have been able to go out to space. So there's a lot of different things that are there because people do imagine all these possibilities and are brave enough to take that step.
The Imagine step reinforces that there's more than one way to solve a problem. It prepares students for the next step, plan, where they'll focus more deeply on the one design they want to create.
So when you get together, you're going to be combining all of your ideas together. And this is what engineers do, is they come up with all these individual Imagine ideas, then they come together and they talk about why would it work, why wouldn't it work.
As Corey explained, during the plan step, groups of students must choose one Imagine idea that they'll further develop and test. Back in 1st grade, Julie introduces the plan step to her students as they choose designs for hand pollinators. Her comments focus on teamwork, encouraging compromise and collaboration.
It's time to make a plan. Draw a diagram on this big box now. Out of all 4 of those, which one do you like the best? And add labels so we know what materials you're using and how they're connected. Are you ready? Okay. Tell me what you have here. Do you guys agree on this plan? Do you like it together? Oh, great teamwork.
So let's say number 3, but we'll suspense it. So it will be half a nut. It would look like your idea, but we'll do the things that are in my idea. Draw by...
I love how you are writing your supplies and drawing what you think it's going to look like. That is great thinking. I'm loving your cooperation.
I wanted to pause here to make sure that we understand. We cannot move our classrooms to this tomorrow, nor did they do it in one day. Okay? It is a process. Alright? But the idea is you embed 21st century skills right from grade 1. So hopefully by the time they come to high and middle, we still, Mohammed and Abdullah are not fighting who is the better one, they're actually working collaboratively. Okay? So it is not something you will do tomorrow. However, make sure you also build in the language, teamwork, collaboration, compromise. Because if 5 of us are working together, it's not one person's idea for sure all the time. You have to give up some of your ideas and that's okay. Okay? So use those teachable moments to build in the 21st century skills. Alright? Because that is a core part of both the Common Core as well as the next generation science standards. Alright? It might require, these classrooms are at least large enough compared to many schools that I go to even in July. This is still comfortable enough for you to group them as 4s. Okay? Group the tables as 4 when they are doing an engineering design process. You don't have to do it every single day but start the process. Alright? So just to give you the idea that this is something you have to purposefully plan.
After discussion, the group records their final plan. They know that they're about to actually create this technology, so they're motivated to label their drawings and write down the materials they're going to need. Only after students have asked and answered lots of questions, imagined several different ways to solve the problem, and come to a consensus about a plan, should they move on to the create step. In this step, students will follow their plan, build, and test their technologies. Needless to say, create is usually the most exciting step for students. Children are very excited to see their designs in action. Sometimes they work as expected, and sometimes they don't. Let's watch a group of 4th graders as they test the model membranes they designed and created. When designing a container for a frog, they used various materials to try and reduce the flow of water to a slow drip.
Too fast?
Yeah. Oh my gosh, he's already like, yeah, that water is on.
Alright, well what can you do tomorrow to improve?
Put a sponge in it.
The improve step is fundamental to the process of engineering. It's important to give your students time to improve their designs. When given the opportunity to improve, students can think critically about what parts of their design are working well. Just as importantly, they can carefully observe what doesn't work. When failure is presented as a learning opportunity and a critical part of engineering, students come to accept and expect it. In this next clip, we see Grace Schofield in the improved step of the engineering design process, as she leads her 5th grade students through the design of a high-quality Play-Doh. Notice how she stresses that the improved step is never complete. Indeed, it's just the beginning of another iteration of the engineering design process.
I'm seeing lots of interesting things going on, all right? Jordan, tell us what's happening at your table.
Oh, we added, like,
What? You went ahead
yeah,
and added?
yeah.
What step is that? You're going to improve the improvement?
Yeah.
Do you see how this is a process? Once you keep doing it, it goes going on and on and on, and you're not done?
Just like professional engineers on the job, your students may not move sequentially from one step of the engineering design process to the other. They may transition back and forth in order to solve the problem at hand.
If you don't do the design process and you want to build something or help with something, you don't know how you're going to make it and you don't know if it's good enough because you're just going to build it and you don't know if you need something or if you need to improve something and it might not be sturdy enough, so you need the design process.
As they practice using the engineering design process, children come to understand that each step in the process is unique, and each represents a critical part of engineering.
So you'll find this video in the Engineering is Elementary